A solid metal cylinder has a base radius of 4 centimeters and a height of 8 centimeters. Find the area of the base of the cylinder. So I've drawn a cylinder here. This is 4 centimeters and the height is 8 centimeters. We're actually wanting to find firstly in A the area of that. Now hopefully all of you are clear that the area of a circle is pi r squared, which is the base of a cylinder. So we're going to have pi times 4 squared. So we put that into our calculators. So we're going to have second function pi times 4 squared, which is 16, and we get our answer of 50.265. So remember to always do it to 3 significant figures. So that's going to be 50.3, and remember to put your units in centimeters squared. So we've got that. Then it says show that the volume of the metal used in the cylinder is 402 centimeters cubed. Given correct to 3 significant figures. Now our formulas are given in our data booklet, and we actually have our volume of our cylinder here. We have the volume is equal to pi r squared times by our height. So we're going to have our volume is going to equal pi r squared times by the height, which is obviously going to be this over here, pi times 4 squared times by 8. And so when going into our calculator, we're actually going to multiply this by 8, because that's our pi r squared there. And we get 402 going here. We're going to get 402.12, which equals, correct to the 3 significant figures, 402 centimeters cubed. Then it says find the total surface area of the cylinder. Now in doing this, we've got 3 surfaces basically. We've got our 2 circles, so the total surface area is going to equal pi r squared times by 2 times this by 2, and that will give the area of that and that. And then we're going to have this curved part here. Now what is that? Now again, we can go to our data booklet. It should give us to us here. The area of the curved surface of a cylinder is equal to 2 pi r times by h. So it's going to be plus 2 pi r, which is 4, times by h, which is 8. So we're going to have all of that. So let's put that all into our calculators. We can do this again. So we're going to have second function pi times by 4 squared, which is 16, times by 2 plus 2 times by our pi times by 4 times by 8, enter, and we get 301.59. Now again, let's do this to 3 significant figures. So that's going to be our surface area is going to equal 301.59, which I would then write as 302. Sorry, this is lagging here. 302 centimeters squared. Now, it's very important that you show this working, that this is shown, so that you can see where this is coming from. Then it says the cylinder was melted and recast into a solid cone shown in the following diagram with the base radius of 6 centimeters. So we've got that. Find the height OC of the cone. So in doing this, I'm going to have here the volume of a cone is given by this formula over here. The volume of the cone is given by this formula over here. The volume of a cone is equal to 1/3 pi r squared h. Now we are told in this that we are told by this that, let me just get this right, sorry, that this metal over here, so this the volume here of 402 centimeters cubed, it's 402 centimeters cubed, is recast. So the volume of this must still be also, the volume of this must also be 402 centimeters cubed. So that's equal to 1/3 pi, but now my radius is 6, so it's going to be 6 squared times by the height. So I'm going to divide both sides by 1/3 pi 6 squared, 1/3 pi 6 squared. Can divide that. That obviously cancels that, and I'll get my height. So getting my calculator out here again. Let's put that into the calculator. I'm going to have 402, but now I want to divide it by all of that, so I must have my brackets. So that's going to be 1/3, so it's 1 divided by 3 times by pi times by 6 squared, which is 36. We can do it as 6 squared, close brackets, enter, and I get 10.66. so my answer for this is the height is equal to 10.66, which is 10.7 centimeters. We then need to find the size of the angle BCO. So we want to find this over here. Now in that we're going to, this is a right angle triangle, this would be a right angle. We've just worked out that this is 10.7. We know this, and so we use our right angle trig formulas. We label it according to the angle that we're dealing with. So this is my opposite, and this is my hypotenuse. This is my adjacent. This over here would be the hypotenuse. I don't know anything about that. So we're going to use opposite over adjacent, which is tan. So it's going to be the tan of theta is equal to my 6 divided by my 10.7. So let's do that. 6 divided by, let's just bring in our answer here, because we've got our answer there, enter. So we get that, and then we do second function tan, second function answer, close brackets, enter, and I get 29.36. so theta will equal to be 29.4 degrees. We then asked to find the slant height of CB. So we asked to find this. Now we could use trig, but probably the easiest way to go with that would be to use Pythagoras, because we've got a right angle triangle. So this is my ABC. We know by Pythagoras that A squared is equal to B squared plus C squared. So A squared is going to equal my B, which is my 10.7, or let me put in 10.66. I'll just use a slightly more accurate for there, plus the 6 squared. And because it's A squared, this is going to, the A will equal the square root of all of that. So let's put that into our calculator. let me clear all of this. So we're going to find second function, square it, put the open brackets. So we're going to have 10.66 squared plus 6 squared, close brackets, enter, and I get my A is equal to 12.2 to 3 significant figures centimeters. So we've got that over there. We've got the slant height is 12.2 centimeters. And then it says find the total surface area of the cone. Now in doing that, let's just firstly bring in our formulas here, and let me just clear this up a bit like that. Now we want to find the total surface area of the cone. Now that's made up of two parts. We've got the area at the bottom, that area over there, and then we've got our curved surface here. So we've got the two parts. So the surface area, if I just do it over here, my surface area is going to be the area of the base will be pi r squared, so it's going to be pi 6 squared plus the area of this curved surface. Now this is this formula over here, the area over here, the area of the curved surface of a cone is equal to pi rl, where r is the radius and l is the slant height. Now we've worked out what that slant height is. It's it's this one over here, it's 12.2. This one over here, the slant height is 12.2. So it's going to be pi, we're going to have pi r, which is 6, times l, which was this 12.2, times 12.2. I'm going to have that, and that will give me my slant, that will give me my total surface area. So we're going to get my second function times by my pi, second function pi, which is that one over there, times by 6, well actually I don't need that, times by 6 squared plus my pi again times by 6 times by this value over here, this 12.23. So I may as well use the accurate version of that by my answer, and I get my total answer there is 343.67. so I'm going to have here, so that's 343.67757. It's always good to put in an accurate answer and then to round it down to your 3 significant figures. So 300, sorry this is lagging, 344 centimeters squared.